Hi, I'd like to demonstrate my latest project. It's a remote control for my Raspberry Pi, so you can use it for home automation, for example. It's the successor to my embedded WebSockets project that I did back at the end of 2011. So what I've done here, I've got all the software set up and running, and I reset the database for my software, so it's just like a fresh install. So I've got my Raspberry Pi here, and my development board, which has an ADC on it. So I'm going to go ahead and connect the GPIO header here and turn it on. And now on the computer I'm going to browse to my local host here for PiIO. So as you can see here, we get the kind of blank screen here that tells us to select a Raspberry Pi, and in here it tells us we have no Raspberry Pis. So like I said, I reset the software, and once it turns on, it'll register itself with PiIO because it's pre-configured to connect to my server, and we'll see that in a moment here. So there it is. It's telling us that it's come online. Now you'll see in this list here, it has kind of like a default name, which is just the MAC address and the local IP of the Raspberry Pi. So if we select that, we get kind of a blank page. So that's just because we haven't set anything up yet. So I'm going to go ahead and open up the admin control in a new window here. So we can choose Raspberry Pis here, and we have this Raspberry Pi that registered itself, so it's showing up in there. And here we can give it a custom name. If you don't like that name, I'm just going to leave it for now. And here we have all the displays that currently function for PiIO. So what I'm going to do, I'm going to add a button display here. So here we can choose the port. So I've got an LED here hooked up to GPIO 17. So I'm going to pick 17 here. The interface is GPIO output. You can build different interface modules for PiIO. So right now we've got GPIO output, input, and ADC. We can call it whatever you want, so I'm going to call it LED. And I'm not going to give it an equation. I'll explain what that does later on. So now if I save this, you'll see that the settings immediately got pushed to any user that has that Raspberry Pi open right now. And now we have this LED display where it tells us that it's currently off, and we can toggle the value. So as you can see here, toggling the value turns the LED on and off. So it's using WebSockets, so the response is very quick. All right, so now let's check out the ADC. So let's add a graph display. Again, you choose the channel and the interface that you'd like to bind the display to. So we're going to bind it to ADC on channel 0. And we'll call this potentiometer. So equations allow us to manipulate the value before the end user sees it. This is evaluated Python code. So this is a 10-bit ADC, which means we get values from 0 to 1023. So I'm going to write an equation in here to convert it to, let's say, the voltage that we get off the voltage divider for the pot. So that's going to look like this. So right now we're converting it to a float from 0 to 1. And then we'll multiply it by the voltage. So let's say it's running at 5 volts. Now if I save that, again we get the settings pushed, and now we have this graph display that holds 10 seconds range, so it's filling up the 10-second buffer, and there you can see it pan. So now if I turn this pot, you'll see that the graph scales itself, and if I go all the way to the end, it'll go up to 5 volts. So again, it's pretty quick. Yeah, you can turn it and see it draw the graph. Okay. Yeah, I've got another display that I wouldn't mind showing here, a bar graph. So this is it's not a bar graph, sorry, it's a progress bar. It's from the CSS framework that I'm using. So I'm gonna go ahead and put a similar equation. So with a progress bar, we need values from 0 to 100. So I'm just going to take that same equation, multiply it by 100 instead of 5, and we'll call this potentiometer percent. Sure. There we go. Again, we can use the same channel that we've got bound down here, so we're going to bind it to the same ADC channel 0, and we're going to apply that. And so here we go. We get a bar graph potentiometer percent for our pot, which now you can see is reflected both in the graph and the progress bar display. Okay, so let's try something else. Okay, so for my second demo, I've got a power bar that I've rigged with a Hall effect sensor and a relay connected to my Raspberry Pi. So here in the configuration, let's change a few things. So the relay is connected to the same pin that I connected the LED to. So let's just call this, we'll call it light. We don't need this progress bar on display anymore. Let's get rid of that. And the graph display, let's connect my Hall effect sensor to ADC channel 3. And let's not use an equation for that. We'll call this power question mark. So unfortunately, I don't have the proper circuit to measure AC RMS. So we're kind of just going to see a bunch of noise from my Hall effect sensor. But let's take a look what happens anyways. So let's save these settings. And here we get our new displays. So Hall effect sensor is centered around the middle of the 10-bit ADC, as you can see here, just kind of noisy everywhere. And let's toggle my light. So as you can see, I've got my power bar connected to my studio lamps I'm using in here, and you can kind of see that the noise has grown a little bit. So we get the indication there that we're consuming power. Obviously, ideally, I'd like to build the proper circuit in there to measure current, so we can have a nice graph display here displaying the watts going through the power bar. Again, the response is very quick, and we can in fact have multiple users running PiIO at the same time. They each get their own graph buffer because the buffer is local, so that's why you have to see it fill up the 10 seconds first. But there you go. I can toggle the light on either one, and the status is immediately updated across all clients listening for that Raspberry Pi. Thank you for watching.